means that the value system is just in name only. It doesn't really affect its core. Think of also other use cases of the word nominal. People will say, oh, that person is a nominal Christian or is a nominal Muslim. It means that they are a Christian or a Muslim in name only. It doesn't really affect their core behavior. So the same thing, he won't say a variable is nominal. It's just whatever number was attached to it is just by name only. It doesn't really affect its core. So we cannot use that numbers for anything serious because it's just a label. So those are the key variables we have: continuous count, ordinal, and nominal. And so again, our focus today will be on ordinal variables. Now let's talk about continuous variables a little bit so that we can distinguish the kind of analysis we do with continuous versus with ordinal. So continuous variable is a parent and they have two kids. The first key is called ratio. The second key is called interval, right? The easy way to remember the difference between two of them is ratio ends with 0. Think of where it ends with O, but think of the O as 0. So that means that ratios have an actual 0. Ratios end with a 0. So that means that the minimum value of a ratio is 0 because it ends with 0. Intervals do not end with 0. Intervals can go below 0. So anything below 0 is obviously minus. So intervals can actually go into minuses, right? So ratios cannot get to minus because they end at 0. Intervals can actually go below 0 because they don't have a true 0. So so that's a litmus test to distinguish between a ratio and an interval. And that's very important to note because it affects the kind of analysis we can do with some variables and the kind of analysis we can't. So it's very important to understand just by looking at the variable and knowing that, oh, this is a ratio variable, this is an interval variable. Because like I said earlier, you can do certain operations with intervals, like plus and minus, whereas ratio variables allow you a much broader realm of analysis types, like plus, minus, division, and multiplication. All right, this is now quiz time. Let us see how much you have been following attention. What type of variable is this? Cars on the road. Is it interval, ratio, count, ordinal, nominal, or unstructured? You can type your answer in the chat box and let's see. How do I see what's been typed now? Okay, I can't see that here. All right, great. So we say count. That is absolutely correct. So that's a count variable. All right. What kind of variable is this? This is the temperatures in this geographic area. And so you have the temperatures listed here. You can see the legend here contains the temperatures that correspond to the various colors. What kind of variable is this from what you can see here? All right, great. We have people saying that is an interval. And remember, that is great because remember, interval versus ratios. Ratios end with 0. So, a ratio cannot fall below 0. But here we can see the values actually fall below 0. You have minus temperatures. In fact, temperature will talk about sub-zero temperatures. Sub-zero means it's under 0, literally. And so this is correct. This is interval. All right. What kind of variable is this? Okay. Excellent. So this is correct. This is a ratio because it's talking about height. It'll be ridiculous to say somebody's height is -5. That does not make any sense. All right. So this is a ratio because it has a true 0. All right, great. What of this? Here we have racial groups, AIAN, white, black, Asian, and Hispanic. Assume we assign values of 1, 2, 3, 4, 5 to those racial groups. What kind of variable would this be? Excellent. So some people are saying count. It's not a count. It's a nominal variable. It's a categorical. We're just saying what racial group do you belong to, right? So, and so even if we added a label, a numeric label like American Indians is 1, white is 2, black is 3, those numbers don't mean anything. It doesn't mean that American Indians, just because they have the value of 1, are superior to or on top of white. That doesn't make any sense. So those are nominal variables. What of this? This is talking about poverty thresholds or poverty groups. And so you have people at the less than 100% of poverty threshold. So think of poorest, poor, rich, richest, right? What will you classify this as? Yes, this is ordinal. That is absolutely correct because there is an inherent ordering of the variables. So that's ordinal. Now, what of this? This is an electronic health record snippet. So we're just typing text into the box. What kind of data will this be classified as? Yes, this is unstructured data, right? And so yes, so we all have a solid understanding of those variable types. This is a great paper that talks about how to analyze Likert scales. And when you get the slides later, you can. I will encourage you to read it. It's a well-written paper. Now let's talk about scale. So now for the rest of the class, since we've understood the general classification of variables, now we'll focus a little bit on type of scales and then zone in on ordinal scales, and then talk about how do we analyze them. So there are different types of scales, and they have implications on how we analyze them. All right. So here we have a scale, and each item is made up of numbers, right? So we'll call this a numeric scale. Why? Because it is made up entirely of numbers, right? So when we take the reading on the value, we can say, oh, this is 9. Sure, we can interpret a value of 9 however we want, but the scale in of itself is made up of just numbers. And so we'll call it a numeric scale. And we can analyze this with means or averages. Now, this is another scale. Similar to the previous one, it has 10 elements. 11 elements or about that. But in this case here, we can see that these elements are not necessarily in numbers, right? There are adjectives that describe each of those, like no pain, very mild pain, and so on and so forth. So this is no longer a numeric scale. You cannot take the average of this. And of course, it increases in an ordinal way from no pain to unspeakable pain. But we must understand that whenever we have a scale that no longer has numbers, we cannot treat it as being numeric. A common mistake people make is that they will have measured the scale with adjectives like this. And then when they are trying to analyze the data, they now substitute those values with numbers. They will now say no pain is 1, very mild is 2. And then they will analyze it as though it was collected originally like that. That doesn't make sense. Please do not do that. You have to analyze the data the way it was collected. So if you collected as numeric, you analyze that numeric. If you collected it as adjectives, well, you have to analyze it as a categorical variable, right? So those will be adjectival scales. And then you have Likert scale or Likert type scales, where, for example, you have strongly disagree to strongly agree. Obviously, it should be clear that this also has this inherent ordering, right? The same with this. So these are adjectival scales, but you can see that there's an inherent ordering in the values from no pain to unspeakable pain. The same thing applies with Likert scales, and those are all, we're emphasizing all of them because all of these variable types are candidates for ordinal regression, because you can see there's an inherent ordering in the categories, both here as well as here. The same thing here, you can see there's an inherent ordering on this pain scale from the bottom of no pain to the very top. And again, this one will only have 3 categories: low, moderate, and high. But we can also see that there's inherent ordering. So the point we're trying to make is that the concept of ordinal or ordering is agnostic of the number of categories. You can have as far as you have at least 3 or more categories. If you have 2 categories, that doesn't apply. 2 categories, there's no ordinal there. You need to have at least 3 categories. So the bottom line of what we're trying to say is that the number of categories is immaterial. What really matters is there an inherent ordering in the scale, right? So here, for example, anybody can see that low, moderate, high, there is an inherent ordering of those values. The same thing applies here. No pain, mild, moderate, severe, maddening. That the same, we can argue that there is an inherent ordering of those values. So those are the scenarios where we use, and then sometimes we have on that scale like anchored scales. Anchored scales typically have an anchor at the end, and then you might have nothing in between. But the user can then use a slider to indicate where they fall. Again, this would be analyzed in that same manner because the intervals here, there's an ordering from the anchors, no pain, to the other extreme. And so in this case, wherever you have categorical variables, what we're focusing on is this row 3. Categorical variables with 3 or more levels, then you use an ordered logistic regression. We went over this slides last week, so I don't think it makes sense to repeat. I'm not sure if we have a lot of people who are just attending this session for today for the first time. But if you were here, we went over this in detail last week, so I will not repeat it any further. All right, so those variable types, whenever we have categorical variables where there is inherent ordering, that is a prime candidate for ordinal logistic regression. So ordinal logistic regression is an extension of logistic regression that allows for a dependent variable with more than 2 ordered categories, like we've seen. And so in contrast to binary logistic regression, where you only have 2 categories, ordered regression handles 3 categories or 4 categories. The number of categories is really immaterial, right? What we care about is that there should be a natural ordering in the categories, like low, medium, high, or the other examples we looked at. There has to be a natural and inherent ordering of the categories. That's when we use an ordered logistic regression. So when do we use ordinal logistic? By the way, you can call this ordered logistic regression or ordinal, whatever your preference is. They say it's the same thing. It's potato, however you want to call it. So you use ordinal when you have an outcome variable that has 3 or more categories, and when the outcome categories are ordered. Again, we are singing it's like a broken bell now. You cannot use this for nominal data. Remember, nominal data is when you have groups and 3 or more groups where there is no inherent sequence or order between the groups, right? So you can't use ordinal logistic regression for nominal data. You use nominal regression for nominal data, use ordinal regression for ordinal data. So here are some examples. Your feedback form says we should provide a lot of examples, so I'm providing you 2 examples here. Customer satisfaction, very satisfied, neutral, dissatisfied, very dissatisfied. You can see that there is, in that Likert scale, there is a natural progression of satisfaction or dissatisfaction, depending on the direction you're looking at. So we can use ordinal regression for that use case. Or pain scales, like the one we looked at earlier, you have low, moderate, high. There's also inherent ordering of those categories, and so we can also use ordinal logistic regression. It's always important to look at, for any model we are using, we need to understand the assumptions behind the model. Now, the major assumption behind ordinal logistic regression is that you have the odds up there. We have proportional odds. So simply put, what that means is that think of this as a ladder. We are saying that the step from here to here is the same as the step from here to here. There's not all. That's the same thing as saying there's no difference between this guy and this guy versus this guy and this guy versus this guy and this guy, right? So we have proportional odds. That is what we're saying. That is a basic assumption we make when we use ordinal logistic regression. And so how do we test that? Well, we need to use a test that will look at, all right, is this step different from this step, or is this step different from the next one? right? That is what the test essentially is doing in simple lay terms. So ideally, we want to demonstrate that the difference between this step and the next one is not significantly different, right? And there are many tests we use for that. We use a brand test or we use a likelihood ratio test. So now this is a pop quiz. If you did a brand test or a likelihood ratio test, would you expect the p-value, for you to use an ordinal regression, would you want the p-value to be less than 0.05 or more than 0.05 if this proportional odds assumption is met? Would we want the p-value to be less than 0.05 or big? What do you really want to see if you do a brand test or a likelihood ratio test? Should it be smaller than 0.05 or bigger than 0.05? Yes, you want it to be bigger, right? Because if the p-value is not significant, it means that you can now agree with the null hypothesis that indeed this distance from here to here is not different from this distance from here to here, right? So that is the null hypothesis is that the distance between those steps. We're using very lay language here now. Just think of this in the context of this ladder. The rungs of this ladder here, first and second, is not different from the one second to third rung, right? Versus the alternative hypothesis that yes, they are different from each other. So if we do a test trying to compare the rungs of this ladder from first to second or second to third, if we are going to believe that the proportional odds assumption holds true, then we expect that there should be no difference. They should all be the same, right? So that is that is in a simplified version of what we do when we test that hypothesis. So we expect to see a non-significant result when we do a brand test or a likelihood ratio test that confirms that yes, we are all set to use proportional odds. My recommendation and my advice would be that every single model you're using has assumptions. So whenever you're using the regression model, try and do at least some basic due diligence to make sure that the assumptions that are required for that model are met before you go ahead with it. We also assume that there is no perfect multicollinearity. We explained what that meant last week, so I will not go over it in great detail. And then that you also have adequate sample size. We will demonstrate how we can calculate sample size for that kind of context where we are looking at an ordinal model in the next at the end of the session. All right, so this is what an output of an ordinal logistic regression looks like. Unlike the previous model last week we looked at where we're looking at multinomial regression. Here you only have one outcome, right? Because in this context, the model is treating is treating. Think of it in a very simple way as the outcome is being treated as almost like continuous, right? And so, unlike in multinomial regression where we're comparing a category of the outcome versus the reference group, in this case, you only have one outcome, one model, right? And that is, again, consistent with what we just explained in the previous slide, that we use the ordinal logistic regression model when we believe that the rungs of this ladder from the first to second is the same as second to third, right? And that's why we have it this way. We're going to talk about the interpretation of this model at the end of the session, but this is just to show you, contrast it with the multinomial regression from last week. And here you have a likelihood ratio test. You can see the p-value is bigger than 0.05. So that tells us that, yes, the assumption that the steps 1 to 2 of a ladder is the same as steps 2 and 3, which is the same as steps 3 and 4, is met. And so we are fine using the ordinal logistic regression model for our analysis. Now, it's very important to realize that when you're fitting an ordinal logistic regression, you have to be careful in what direction you want to interpret it. So if we have a ladder, right, think of it, a ladder, you can only be, whenever you're on a ladder, you can only be going in one of two directions. It's either you are ascending the ladder or you are coming down the ladder, right? That's the only two directions you can ever be on when you're moving on the ladder. You're either ascending it or descending it. The same thing with an ordinal logistic regression. Whenever we're using an ordinal regression, the results can only be interpreted as ascending or descending, right? So when we interpret in the context of ascending, we are saying, what are the odds of moving from one category of the outcome to the next, the higher category? So let's go back here. Let's go back to this slide here. So in ascending, we're saying that, let's say we're talking about the lowest from maddening to, sorry, no pain to maddening. For ascending, we're moving up this ladder. We're saying the odds of moving from one level to the next level, higher level, obviously, since we're talking about ascending. So the odds of moving from no pain to mild, or mild to moderate, or moderate to severe, or severe to maddening, right? So we start from the lowest and we're climbing up the ladder, right? So the odds, you are going to interpret them as the odds of having a higher level of the outcome. Remember, you can almost relate it to the same context as interpreting results from the linear regression. We'll say the odds of per unit increase, or moving from a lower level to the next level of the outcome. When we are descending, we are already at the top of the ladder and we're coming down the ladder, right? So you are at the highest level and you're saying the odds of moving to a lower category, right, of the outcome. So think of it as a ladder. You're either moving up the ladder or down the ladder. So you have to choose when you're doing an ordinary regression. You, the researcher, will have to choose whether you want to interpret your results in an ascending manner or a descending manner, because it's ordinal, it's ordered, and you have to either move up the ladder or down the ladder. So that is how you want to think of it. Now, which should you use? Should you use an ascending or should you use descending? It's your choice. But in general, most lay audiences are more prone. It's easier for them to understand things that are ascending. So people understand, oh, the odds of having more pain. Having more pain is a more intuitive interpretation than saying having less pain, right? So that is, it's a more intuitive. Again, the other one is descending is as valid as ascending, but just in the context of interpretation and and just understanding to a lay audience, it's easier to understand when we move from low to high progressively in an ascending manner. But you have to specify this when you analyze your data. So let's now take the three. I'm always curious, how are these red points? How are these things generated? Like, Lungile, do you know? These red markings, like I'm always wondering how people generate. How are people making those marks on the screen?
Yeah, I asked Semi. I saw who it was today, luckily, and I asked Semi to erase them. But maybe
So, like, what's the
now
mechanism? Like, how does it happen? Like, I'm just curious.
they're taking notes, apparently.
Oh, I see. Okay. Sometimes if I find it quite distracting. All right. Oh, all right.
Ah, statistician. I see you.
All right. It sounds good. Okay. Please, if you can kindly start making notes on the screen, that would be great. All right. So let's take the lessons from the past 3 weeks and put them together, and let us see how, just operationally, the way we fit those models, how they differ from each other. Like, in terms of just doing it, how does it differ when we use a binary logistic regression, or when we use a multinomial regression, or when we use an ordinal logistic regression? So this is binary logistic regression. Like any other regression, you have to select an outcome, one outcome in binary logistic regression. So we're just trying to tie together all the lessons we've had in the past few weeks together, so we can see the differences in the approach between all we've discussed in the past few weeks. So with binary logistic regression, you select one outcome. Of course, with all the other ones too, you select one outcome. For binary logistic regression, the outcome must be, obviously, as the name implies, binary. Binary means it has two categories, 0 and 1. And you also select the predictors, and you select a reference group for each predictor. And then you do your analysis, whether it is in your entire data set or a subset of the data set. So that is the same thing, right? For for binary logistic regression, the similarities is that you will always have to select an outcome. You will always have to select predictors. You will always have to select the reference groups for the predictors. The difference between the different types of regression is here in the outcome, what happens in the outcome. So let's go over to the next screen and see how the setup for a binary logistic regression is different from a multinomial logistic regression. Now, this is multinomial. Like in binary, we select our outcome. Same thing as before. We also have to select the predictors. So there's no difference between what happens with the predictors here. We select the predictors and we select the reference groups for the predictors. The difference in a multinomial regression is that when we select the outcome, we now have to choose one reference category for that outcome. And the results are framed in relation to that category we have selected as a reference group. So if you notice, we didn't have this in the outcome for binary logistic regression. We just selected the outcome, and that was nothing. We didn't have to select a reference group, nothing of that nature. We just selected the outcome. Here with multinomial, we select the outcome, and then we have to select one reference group for that outcome. Now, with ordinal, we select the outcome as before. Now we have to sort that outcome. All right. So because the variable in your data set may not be sorted, so you have to sort it. You have to tell the computer what does it look like in a sorted form. And then you have to choose whether the analysis will be done in an ascending direction or a descending direction. Again, ascending is that you want to see if the outcome increases as the predictor increases. Descending is if you want to see if the outcome decreases as the predictor increases. So are you going up the ladder in terms of the outcome, or are you going down the ladder in terms of the outcome, right? So those are the differences between the regression setups. Again, everything about the predictor is exactly the same. The only difference is what happens in terms of the outcome. How do we treat the outcome? Do we sort it? Do we have to specify, direction? Obviously, direction only matters if it's an ordinal variable. So again, just to understand from a very, very basic, simple level, no complications of just to understand how they're different in terms of the different regression models and their setups. All right, so how do we calculate sample size for ordinal logistic regression? So if you're doing a data collection, you can treat the so I can see some hands up, but based on the feedback we've received from the previous surveys, I think the general preference is that we should finish the lecture and then we'll take questions. So I see your hands. I just want to recognize that we see your hands up, that we'll just finish the session and then we'll take questions and then we can continue from there. So I'll finish a few slides I have and then I'll take questions and then we'll do a demo of sample size calculation and then we'll take it from there. So if we're doing a survey in which we are planning on using an ordinal, we can treat the ordinal as a continuous variable and calculate our sample size based on that. But if we want to be more conservative, sample size calculation for a continuous variable will almost always be smaller than the sample size for a categorical variable. So in general, it's always best to be conservative and to plan for the worst. It does you no good to always plan for the best case scenario. You want to always plan for the worst case scenario. So even if you're going to use an ordinal regression model, and you want to plan for the worst case scenario, well, you can consider that variable to be categorical for the purpose of sample size calculation. Because remember that you might collect your data and you might change your mind, or you might want to do some other analysis. And so always treat your studies as projects, where you can think of your study as, this is a project that will have many studies in it. And so granted, this study might require a sample size of 200, but the next study might require a sample size of 400, and so on and so forth. So I want to plan this project so that I have the sample size that covers everybody. So that's a good way to think of your studies. Think of them as, especially when you're collecting primary data, don't plan for the best case scenario, plan for the worst case scenario. So while you can use the ordinal variable in the context of the continuous variable for sample size calculation, it's better to use categorical approaches to ensure that you are planning for a worst case scenario. We also talked about the rule of thumb for events per variable last week. This is an exact same slide from last week, so I'm not going to repeat myself. This is just in the case where you already have data available and you're trying to use the rule of thumb to see whether you just have enough people for the study. So essentially, we want to have 10 observations per predictor variable category or per parameter estimated. Again, this was covered in detail last week. You can review the slides or the lecture notes from last week. So now how do we interpret the different regression models? Let's look at the case study and let's tie everything we've covered and see how we interpret them from beginning to the end. So our case study is looking at exploring factors associated with favorability or public support towards a ban on menthol cigarettes. So we did a national survey and we asked people, hey, do you support that we ban menthol cigarettes? Right. And so people answered on the Likert scale. And so we're trying to see what factors are associated with public support or favorability towards a ban on menthol cigarettes. And so the outcome variable is favorability towards a menthol cigarette ban. This was measured with a 5-point Likert scale: strongly disfavor, somewhat disfavor, neither favor nor disfavor, somewhat favor, and strongly favor. So as you can see, we can argue this is an ordinal variable. The independent variables or the predictors are, we have age, we have race, gender, and tobacco use status, classified as ever smoker or never smoker. So our exercise now is to see, how do we fit this research question? How do we answer this research question with 4 different models? And how do we interpret it? So that the goal is to familiarize all of us with differences in how we approach and interpret those models based on the approach we use. So we're going to look at it from a binary logistic regression, where we decided to dichotomize, just collapse those groups into just 2. We said, if you answered the extreme 2 values, somewhat favor or strongly favor, you are classified as, yes, you favor a ban on menthol cigarettes. And any other response, which is strongly disfavor, somewhat disfavor, or neither favor nor disfavor, means that you do not favor a ban on menthol cigarettes. So that's the first use case. We're going to dichotomize this variable into 2. Dichotomy means 2 things. So we're going to create a binary variable. Binary also means 2 things. And use as the name implies, binary logistic regression. So that's the first approach we're going to use. The second approach we're going to use is, we're going to say, well, we don't believe that the proportional odds assumption holds true. And so we prefer to treat these categories as nominal, not as ordinal, right? And so, there's a question. So the dichotomy would be either favored. Yeah, well, the question is factors associated with favorability, right? That the dichotomy is driven by how we want to frame the research question. So it's not a rule, it's your preference. If you wanted to frame the research question as, what are the factors associated with opposing the ban on menthol cigarettes, right? Then your dichotomize is that strongly disfavor and somewhat disfavor versus the rest. So the point is that it's not a rule in set in stone. It depends on how the research question is being framed. In this case, we're looking at factors associated with favoring a ban. But if we were looking at factors associated with opposing a ban, it would be opposed versus not opposed. In this case, it's factors associated with favoring a ban, so it's favor versus not favor. All right, I hope that's clear. Multinomial logistic regression, again, where we're looking at this variable as nominal, not ordinal, right? So we're going to pick a reference group and we're going to see how that works. Next, we're going to look at an ordinal logistic regression, right? We're treating this variable as ordered, because we argue that it's an inherent ordering of the variable. And we're going to treat it as an ascending direction. We're going up the ladder. So the question is, how do we interpret that? And then lastly, we're going to look at an ordinal logistic regression and treat it as descending odds ratios. And again, how do we interpret that? So that's the whole point. Well, this is just to tie together all the things we've covered in this bootcamp and say, what's the difference? What forms the basis for deciding on one approach versus the other? And more importantly, how do you interpret? If you notice the issue, we're not even worried about issues of code. You can figure out the code in 1 minute. So we want to focus more on the principles and and the judgments and interpretation. That is far more important than the code, which is just a one-liner that you can get, you can figure out in 1 minute, literally. All right. So let's look at the first scenario here. Binary logistic regression. So our goal is to explain everything on this table and understand so that you develop an intuition for understanding and interpreting these things. So here we have decided to take those categories and dichotomize them. Again, dichotomize means to collapse them into two categories, all right? And why are we dichotomizing? Well, because we want to use a binary logistic regression. And why do we want to use a binary logistic regression? Well, because it's easier. People just understand things easiest in binary. Oh, yes versus no. Married versus unmarried. Dead or alive. That is the simplest way you can convey anything to anybody in the world. Research is not just about, the numbers and, showing up. Research is all about communication. So sometimes we just want to use a method that's just simple for people to use, right? And if you want to, the simplest way to convey anything again is binary. Everybody understands binary in the world. So that is the reason why we are using binary, because we want to make sure that people understand it. And so we have chosen to take that variable and collapse it. Now, why are we choosing to collapse it versus these two ways? Why do we choose to collapse it as somewhat favor versus strongly favor? Well, many reasons. Maybe that's how it has been done in the previous studies. It's also from common sense. It makes sense. Somebody says, well, I somewhat favor or I strongly favor. It's clear that they both favor it, right? To varying extents, but they favor it. Now, you have to realize that the moment you choose to collapse any variable, you are losing information. You are simplifying the whole data that was collected. So obviously, you lose some information and you lose some nuance. So you can't start complaining that, well, I don't think that somewhat favor and strongly favor are the same. It's like, yeah, but you have to make up your mind, okay? Do you want to simplify? Once you simplify anything, that means that you're losing information. And that's the cost of simplification, that you lose precision and you lose nuance. So you can't have that and then still complain, So we have chosen to dichotomize it as somewhat favor and strongly favor because, well, literally, they both contain the word favor in them. So that means that these individuals favor, and the rest will be called people who do not favor. Be careful how you use the language. Don't say people who favor versus people who oppose. That is technically not correct because it is favor versus not favor. Because you also have that group here that says neither favor nor disfavor. They are not opposing, they're just in the middle. So if you are going to collapse these two extreme values, somewhat favor versus strongly favor, and all the other three remaining into one category, just be careful to not call them favor versus oppose. It's favor versus not favor. Now, somebody else can decide to say, well, I am not necessarily interested in some people who are lukewarm in favoring. I want people who are strongly favor the ban. In which case, I can choose to categorize it as strongly favor versus all the rest. Is that wrong? No. That depends on what the research, but of course, in that case, that's a completely different research question, right? So the bottom line is that you are the researcher. You have to embrace and be in comfort with your authority as the researcher. And that comes with decision-making, right? Young researchers always want to push the decision-making to somebody else to make decisions for them. Like, hey, please tell me how I should categorize it. Like, is it my study? Like, why should I tell you? You are the one doing the research and you're asking me to tell you how to categorize it. So it's your study. You are the decision maker. You are the chief decision maker, right? But you should be ready to back up whatever decision you've made with a justification for it. So if you choose to look at favor versus all the remaining ones, why? Why? And it's not even a trick question. It's just, why did you do it that way? If you just look at it from the context of oppose or people who do not favor versus like why. So it's not a trick question. Just be ready to provide a defense for why you've done it that way. So in this case, we've chosen to look at strongly favor, which is the most extreme category, versus all the other ones: strongly disfavor, somewhat disfavor, neither favor nor disfavor, or somewhat favor. Why are we looking at just one category, the most extreme category? Well, we can argue that we are interested in individuals who are very strongly in favor of that ban, because these are the individuals who would, if the chips are down, I would say, guys, we want to have a rally, right? We want to have a demonstration to maybe at the Capitol, or to promote support for bans on menthol. These are the guys that are going to come out in the rain and the sun and in the snow to support that rally. So we're not just interested in some guy who have some lukewarm, support. No. We want the veteran supporters who will come out in any, season to support the policy, right? We want people who will actually act for what we're trying to do, right? That is my defense. Again, my defense may not be the same as your defense, but the point of what we're trying to say is that you as a researcher should embrace decision-making, and you should be ready to support why you selected. So in this case, we have chosen this one category versus all the other ones. Why? Because, well, like I said earlier, we're interested in, people who have strong support and who will be willing to support the policy in, to its final execution. So, but this is not written in stone. That's the bottom line. It's your call as a researcher, but you should be able to support it with a justification. Don't just select a group and just allow us to be wondering why you selected it that way. That's the point we're trying to make here. All right. Now, let's move on to the rest of the table and see why we have done things certain ways. So here, and please, another lesson here is that once you provide the categories, please let us know explicitly what belongs to each group. So don't just say the outcome was strongly favor. Okay, strongly favor versus what? How do we know that you have not treated people who said neither favor nor disfavor as missing values? How do we know? So again, explicitly state what is in the outcome categorized as success, but also explicitly state what is categorized in the other category that is a failure. So you must provide those two categories. So that's the lesson we want to learn from this. Now, here we have the table. The table has, the first column here is the variable. The variable, these are the predictors. The outcome does not appear anywhere in the table. So that's the first thing you notice, right? So the table does not contain the outcome because it is the outcome. Our outcome is support for a ban on menthol. You can see there's no support for menthol in the table because it is the outcome. Now, we have the intercept here, and then we have the predictors. Remember that age was a continuous variable. Age, continuous variable in years. So continuous variables also do not have reference groups. So you see, race is a categorical variable. We said that race had categories as white, black, Hispanic, Asian, and other, right? And we've selected the reference group as white. When you select the reference group will also not have results of itself. So why? Because it's a reference group where we are using it as the benchmark, right? So that is why the reference group does not have results. It's a problem when you read the paper and you see the person specified that this is a reference group and also displayed the values for the reference group. That does not make any sense. So please, do not do that. Whenever you have a categorical variable, you should specify the reference group, even if it's just binary. And so here I've shown you what not to do. This is a bad example here. So you can see that gender has two categories, male and female. right? Gender, binary, male, female. Tobacco use also is binary, ever versus never smoker. So here I've tried to show you a bad example of what to avoid. So the gender here, this is a good example, right? So even though it's a binary variable, the table explicitly tells us what the reference group is so that we're not assuming. This table, this tobacco use here, we are left in a situation to start wondering, what does tobacco use mean? Like, is this binary variable? If it's binary, what is being compared to what, right? So what we should have, how you should present it is you should present exactly the way we presented gender. So here you should have had tobacco use. The reference is never smoker. And then the next line you will have smoker. And then you present the results for smoker category. So I did this intentionally to show you how not to do it, right? So even if the variable is binary, please do not just show that variable like without telling us what the reference group. The only time you can do this is when you have like age. See, age is continuous, right? So once I see a variable like this without any reference group, I'll automatically know it's continuous. So that means there's no reference group. Rather, we're capturing it per unit increase, meaning from age 1 to 2 or 2 to 3, how does that change the coefficient of the outcome? So this is that about this column, the variable. This is for the predictor variables. The outcome variable, like we mentioned, does not appear in a table. Why? Because it is the outcome. Now, this is a very important value here, the intercept. The intercept means what is the result, what's the odds of the outcome when everything is at the level of the reference group. So in this case, the reference group for race is white. The reference group for gender is male. The reference group for tobacco use is never user. And for age, we are centering that in mean. So the question is, what is the odds of being a tobacco of reporting favorability when we have mean age and among people who are white and people who are males and people who are never tobacco users? So the intercept tells us the value when everything is set at, at the baseline or at the reference group, right? And it's very important to report it has no real interpretation in terms of the result of a study, but it's always a good practice to report everything, right? So in terms of just modeling good behavior, I have included the intercept here to show you that, yes, it's always great, even though it has no real world interpretation for your study. In terms of showing the complete results, well, it's always a great thing to show the intercept as well, even though it doesn't have any real world interpretation. But again, this table is just show us the good things we should do and the bad things we should avoid when capturing our results. So far we've looked at one bad thing we should avoid, which is here we have tobacco use that was a categorical variable. We have failed to show the reference group. That is a bad thing. We should avoid it, right? We should have shown the reference group the exact same way we did for gender, male versus female. Now, the next column here is the coefficient. Ideally, you don't have to show the coefficient, but I just included it so that we can see and avoid a mistake some people do sometimes. Now, sometimes you have young researchers who would mistakenly display the coefficients and misinterpret it as the odds ratios, right? So that's the reason why I included this here. Oh, by the way, these are all dummy results. These are just dummy hypothetical results. So please do not display the coefficients and misinterpret them as odds ratios. It's okay to display them if you want, but you must interpret them as log odds. Again, remember in session 3, we explained everything about the difference between log odds and odds ratios. So when you take the exponents of the log odds, that is how you get the odds ratios. So please do not interpret the log odds as odds ratios, because that is completely wrong. Odds ratios cannot be negative. You cannot have a negative odds ratio, right? So odds ratios can only be positive. So if for whatever reason you wish to display the coefficients, sure. It's not typical, but there's no rule of thumb saying you must display the odds ratios in the table. If you want to display this, sure, you can, but interpret it in the correct context, which is as log odds. And if you want to convert the log odds to the odds ratios, you just take the exponent of this. All right, now let's focus on the major part of our table, which is the last 3 columns. So here you've seen I've displayed the p-value and the 95% confidence intervals. This is completely unnecessary. It is not, it is completely redundant, showing the p-value and the confidence interval, right? Because this is more important than this column. So if you have a choice to pick between the 95% confidence intervals and the p-value, please always choose the 95% confidence intervals, because this tells us a whole lot of things that we can get from here. The odds ratio tells us the magnitude, it tells us the direction of the results. For example, this, just by looking at the odds ratio, you can see that this is 0.1, 0.3. It tells you direction, right? It tells you that this is below 1, and so there's an inverse relationship. But it also tells us the precision. It tells us that, oh, wow, these confidence intervals are not very, very wide. You can see these confidence intervals are quite narrow, right? So that's great. And so it tells us both that this is significant. How do we know this is significant? Well, you look at the odds ratios, 95% confidence intervals. You want to check whether it includes 1 or not. If the confidence interval includes 1, that means that the result is not significant, right? So here, the confidence interval, the lower one is 0.1, the upper one is 0.3. See, both of them start with 0 points, 0 points. That means that it doesn't include 1. So think of a number line. You have 0.1, 0.2, 0.3, 0.9, then 1, then 1.1, 1.2. So this doesn't include 1, obviously. That already tells us that this result is significant. Why? Because it does not include 1. Here, we look at the confidence intervals, 0.9, 1, 1.1, 1.2. So this includes 1. You don't need a p-value to tell you that this result is not significant. This is already obvious as day that it is not significant. So because you have 0 point here, and then you have 1 point on the other hand, it tells that that's not significant already, right? So the bottom line is that, please, when you have a choice between the 95% confidence intervals and the p-value, always choose the confidence interval, any day, anytime. Now, why do we choose 95% confidence intervals? Like, must it be 95% confidence intervals? No, you can choose 99% intervals. Especially when you're just doing exploratory analysis, you can choose, 95% intervals. Now, quick quiz, a pop quiz. If you use 95% intervals versus 99, do you expect the confidence intervals to be wider with 99 or to be narrower with 99? What do you think? If you use 99% confidence intervals, will the confidence intervals be wider or narrower? Oh, I'm getting completely contradictory results. Some people are saying wider, some people are saying narrower. Okay, think of it just from common sense. 99 and 95, which is wider? Is 95 wider than 99, or is 99 wider than 95? 99 obviously is wider. So you're going to get wider confidence intervals with a 99%. And why do you think what's the basis for trying to use a 99% confidence interval? What's the mathematical basis? Like, or what are we trying to avoid? Well, in the context of an exploratory analysis, because you might submit your paper to a journal and the editor-in-chief tells you, well, it seems you are doing a lot of exploratory analysis here. To be conservative, please, can you kindly use 99% confidence intervals? What is the editor-in-chief trying to avoid? Excellent. I see I see correct answers there. Who wants to unmute and explain to us why a 99% confidence interval will reduce error, type 1 error? Does anyone want to unmute? And I see, let's see, who answered that correctly? Pastor George, you are absolutely correct. Do you care to explain to us why a 99% confidence interval would reduce the likelihood of a type 1 error? First of all, let's explain what the type 1 error is you're on a fishing expedition, right? You just find results just by chance. Yeah, sorry, hand. Mohammed, please go ahead.
Okay, thank you. I think it's about the margin of error. So with 99% confidence interval, you have a wider margin of error. And also looking at your the Z distribution, you are using a Z distribution constant of like 2.58, which is far bigger than 95% confidence interval, where you are using a Z constant of 1.96. So
Okay.
as a result of that, you tend to cover more wider range of sample size compared to that of 95% confidence interval.
Okay, thank you. Now, I want somebody else to explain to us in a very simple way, right? Remember we said that 95 and 99, which is wider. So let's start from basic principles. 95 and 99, which is wider, which will give you wider confidence intervals.
99.
99, exactly. So if 99 is wider, which one has a higher likelihood of containing 1? 95 or 99?
99 still.
Yes, it's wider. So the likelihood that it's going to contain 1 is, of course, it's wider because so it's going to contain 1 more easily. And remember that once 1 is inside that odds ratio, what does that mean?
Not significant.
Not significant. So the editor-in-chief is saying that, well, you're just exploring so many variables here that I think you're just going to find things that are significant just by chance. So to reduce the likelihood of that, please expand the confidence intervals. I want them to be wider so that it's more likely it's going to include 1, so that that reduces the risk that you just find spurious results that are significant just because you are looking so hard, right? So it's not unusual to see such recommendations from editors sometimes when you're just doing exploratory analysis, and I request that you use 99% intervals as opposed to 95. But I just wanted us to understand it from just a simple, a common sense approach, why that recommendation is provided and why that makes sense. So again, remember, if it contains 1, that means the result is not significant. 1 is like a null value. And what is special about 1? Well, remember that we're talking about odds ratios here. A ratio means you have one number at the top and another number at the bottom. 4 divided by 4 is 1. 5 divided by 5 is 1. So that means it's obvious that when we have 1, that means that the number at the top is equal to the number at the bottom, or the number at the top is not significantly different from a number at the bottom. So that's the special thing about 1. 1 means a null value, where the number at the top and number at the bottom are the same. So that is why we say that when your confidence intervals contain 1, it means that the two groups you're comparing are not different. The number at the top and the number at the bottom are the same. Well, statistically, they're not different, right? And that's the whole basis. We say, all right, let's use a 99% interval because the confidence intervals become wider, and the likelihood of catching 1 in a wider confidence interval is higher. And so it reduces the likelihood that we have a type 1 error, which is that we have a fishing expedition and we're just trying to find things when they don't really exist in nature. So that's the whole basis there. So bottom line, was saying that confidence interval gives us more information than the p-value. And so again, you want to prioritize that. When you're reporting p-values, please do not report p-values of 0.000. That doesn't make any sense. So this is the reason why we added this here for instructional purposes. If your p-value is 0, you can put it as less than 0.001. Please do not put the p-value of 0. That makes no sense. So now we've understood the table. Now let us interpret this parameters. Well, we've already covered this from the last class. Who wants to volunteer and interpret the coefficient for age? So remember that age is a continuous variable. So who wants to, and the result is strongly favor versus the others. So who wants to volunteer and interpret this coefficient, what it means for age? Why is this so suddenly quiet, quiet, absolute quiet here now?
Please raise your hand if you want to answer.
Tony, yes, Tony, is that a thumb up or a hands up to answer?
Samson has. Okay. Samson wants. Samson, you can unmute yourself.
All right. So I think increasing age is associated with 1% increased odds of being strongly in favor of a ban on smoking, like as in the type of smoke we are talking about, compared to not being in favor. But this is not significant. Thank you.
Now, not go away yet. Increase age, you're almost there, but you did not qualify the increase age, like increase, like from 10 to 20 or what? Like, what do you mean by increasing age? There's a specific language we need you to provide for us. What kind of increase in age are we describing?
Okay, from 18 years to the smallest age category we have in our study to the highest age.
You've taken us into the bush now. So remember that age is a continuous variable, right? We're measuring it continuously, 18 to, so when you say increasing age, do you mean 18 to what? We're saying 18 to 19, right? And 19 to 20, right? That's what you mean, right?
Yes, exactly.
And so what do we call that? For every unit increase.
Okay.
Unit increase means that we're moving from 18 to 19, 19 to 20. All right, now take all of that and can you now reframe your answer?
Okay, so for every unit increase in age, there was 1% increased odds of being strongly in favor of the ban on smoking, as in the specific type of smoking we are talking about here, compared to being compared to not being in favor. But this particular association was not found to be statistically significant.
Excellent. So for every unit increase in age, there is a 1% increase in odds of reporting being strongly favored against menthol bans. And like you said, the results were not statistically significant. Now, you used 1% increase in odds, right? Which is a relative way of framing it. Remember, we said you can take this value, subtract 1 from it, and multiply by 100. For those of you who were not in our first session, third class, please, you can go and watch the video on how we can express. But we said there are 2 ways we can express this value: a relative way or an absolute way. We can call this the exact way it is, 1.01, or we can say a 1% higher odds. Where are we getting the 1% from? We say, take this number, subtract 1 from it, and multiply the result by 100. So 1.01 minus 1 is 0.01. Multiplied by 100 is 1%. That's where he got 1% from. So he says that for every unit increase in age, there's a 1% increase in odds, or 1% higher odds of reporting being strongly favored against menthol bans. And the result was not statistically significant based on the confidence intervals and p-value. But who wants to interpret it in the other way, just based on the absolute value of this p-value, of these odds ratios? We don't want to say 1% higher odds. And that is correct, by the way. But we want to also make sure that we know how to use both ways of interpreting it, both the relative way and the absolute way. So do we need another volunteer to interpret it, not the relative way of saying 1% odds, but using explicitly this number, 1.01. We want 1.01 to appear in your answer.
Tony, just lowered your hand. Would you like to give it a try? Please go ahead. We can't hear you if you're speaking, Tony. The volume is
sound
very
very-
low.
Okay.
Oops.
Okay, maybe we can have another
Someone
volunteer.
else had their hand up. Passy, George.
Yes, I'm hoping I'm being heard. Network was bad. But for every 1 unit increase in age is associated with a 1.01 odds of favoring a ban on menthol compared to non-favoring, but the results are not, but the estimate is not statistically significant.
Okay. Now, if you're using the absolute approach, the word times must appear in your answer. So 1.01 times higher odds. So if you're going to use the absolute approach, make sure the word times appears. If you're going to use the relative approach, please make sure the word times does not appear in your answer. So we didn't say 1% times higher odds. No, that's wrong. We just said 1% higher odds. If we're going to use the 1.01 raw or absolutely, we'll just say 1.01 times higher odds of reporting. So with every unit increase in age, there was 1.01 times higher odds of reporting being strongly favored against menthol cigarette use, right? So that's how, but the result was not significant. So that's how we can interpret that. All right, we need a volunteer to interpret the value for race, right? So let's say for the row black, how do you want to interpret that result?
Please raise your hands. Okay, Samson again.
Right, so compared to being a white, being a black was found to be associated with 26% increased odds of being strongly in favor of the ban on smoking than not being in favor. Thank you.
So why do you say higher?
Oh, sorry. It's the reduced odds. Okay, so the coefficient show negative, and then it's so. Let me come again. So
Okay.
compared to being a white, being a black was found to be associated with 26% reduced odds of being strongly in favor of the ban on smoking compared to not being in favor.
Okay. Were the results statistically significant?
And this wasn't statistically significant.
Excellent. That's great. And then let's see, can somebody interpret the results for female?
Promise.
Okay, I think that females has compared to males has 0.95 times less likely to be in favor of banning menthol cigarettes compared to their male counterparts, and it's statistically not significant.
Okay, thank you. Excellent. But you use a taboo word which we never ever want to hear. Who detected what that word is? Am I the only one who heard that?
Less likely.
Less likely.
Likely.
They
Why?
yeah.
Likely, right? So that's the word, right? Likely. We don't want to hear likely when we're talking about odds ratios. So do you want to reframe, or does somebody else want to help reframe the answer? And who can explain to us why we don't want to hear the word likely? We talked about this extensively in the last class or 2 classes back. Why can't we use the word likely in the context of odds ratios?
Tony?
If you're using likely, is like you're not sure of the probability. So it's like it's counterproductive.
Okay, thank you.
Like you are actually predicting, and at the same time you are saying you're also not sure of what you're predicting. So it goes both ways.
Okay, thanks. Now, mathematically, it's a ratio, an odds is a ratio of what? To what? To probability.
Of two variables, numerator and denominator.
Okay, so well, you guys will have to go and review the lecture slides from like week 3 to see why we said that, and so why, because in those slides we talked about the derivation of an odds and the odds ratios. And so but essentially you have probabilities canceling each other. The probability at the top, probability is the same thing as likelihood. So the ratio of two likelihoods it results in just simply odds. So you can't express an odds as likelihood because the likelihood at the top cancels the likelihood at the bottom. And so odds are just odds. All right, so the moral of the story is, please, when you're trying to describe results from a binary logistic regression, try your utmost to avoid using the word likelihood, because odds are odds, and we're not talking about probabilities here, we're talking about odds. So, but otherwise, your answer was correctly spot on. So do you want to reframe your answer and use the word odds instead of likelihoods for the results you just described here? I don't know if they already... Okay, go ahead, please.
Okay, I think that females have 0.95 less odds of being in favor of 0.95 times or less odd of being in favor of banning menthol cigarette, which is not statistically significant.
Thank you. Now, again, not picking on you, but you also want to be very precise in how you use the language for the outcomes. It's not just favoring menthol. It's strongly favoring, because remember, we're looking at strongly favor versus the others. So saying that the results are favored, it doesn't really capture the nuance. So like you rightly said, females have 0.95 times lower odds of reporting being strongly favored against a ban on menthol cigarettes compared to males, but the result was not statistically significant. All right, so that is how I think we've highlighted the important points enough. I think all of us should be clear on this. So that's how we interpret the results of a binary logistic regression. All right, let's move on to the multinomial, which was our topic for last week. So remember that with multinomial, we chose one group as a reference group, right? In this case, we use strongly favor as the reference group. Now, with multinomial regression, it means that you're going to have the number of outputs will be, k minus 1, right? So here, the categories originally were 5 categories, 1, 2, 3, 4, 5. We're using strongly favor as a reference group. So that means that we're going to have 1, 2, 3, 4 different outputs. For binary logistic, we had just one output, just one, the same research question, one output. Now, we are supposed to have 4 outputs, but we had decided earlier to collapse individuals who said neither favor nor disfavor. We collapsed 2 groups together. Let me see which one was that. For simplicity, 2 groups were collapsed together so that we don't have too many groups because of sample size. So now we have 3 outputs. Again, contrast that with the previous one where we have only just one output. So in multinomial regression, the moral of the story is that you're going to have, if you have 4 groups, you're going to have 1 reference group, and therefore you're going to have 3 outputs, unless you decide to collapse the outputs like we did here. So here we're looking at somewhat disfavor versus strongly favor. Here we're looking at neither favor nor disfavor versus strongly favor. And here we're looking at somewhat favor versus strongly favor. So strongly favor is the reference group. We, for the sake of this, just pretend that we have collapsed for sample size reasons. We've included neither favor nor disfavor with the other category, which is what? Somewhat favor, strongly disfavor, I believe. Yeah, strongly disfavor. So the point here is that you're going to have, I just decided to display 3 tables just for space of a screen. We don't want to have many screens. So if you have 4 groups, one is a reference group, you're going to have 3 outputs. So that's what we're trying to emphasize. If you have 5 categories, one will be the reference group, so you're going to have 4 outputs, right? If we had enough space here, we'll have had 4 different outputs because we have 5 categories, one is the reference group, the other 4 outputs will be displayed, right? So this is how results from a multinomial logistic regression will look like. Again, contrast it with the previous one, which was binary. We only had 1 output, right? Here we have 4 outputs because we have 5 categories initially. Sorry if this is confusing. I'm telling you there are 4 outputs, but I only have 3 displayed. That's because there's just space for 3 tables on the screen. So, but to align is what we're displaying. Just pretend that we decided to collapse 2 categories together, just for sake of learning. Now, how do we interpret this result here? So remember, this category, they strongly favor is the reference group, and we are now comparing each of the other categories against that strongly favor, right? So this table is comparing somewhat disfavor against strongly favor. So now, based on that, right, with that in mind, who can interpret the result of this black row? And I hope this is big enough. How do I expand this? Okay, great. So again, we still have many outputs on the same table. We're just expanding it to just focus on one. Now, who can explain this result here, this row here? No takers?
Oh, Tony, sorry, I was muted.
Hello? Hello?
Yes, Tony.
Hello?
We can hear you clearly.
Okay. I said compared to the whites, blacks have 0.78. They have 0.78 odds of reporting somewhat odds of reporting strongly favored compared to somewhat disfavored and strongly disfavored. Sorry.
Yeah, completely confused us.
Okay, so let me try again. So I said, yeah. I'm trying to. Okay, so compared to whites, blacks are at 0.78 odds. I don't even know how to speak the English again. Blacks have 0.78 odds. I don't want to use less likely now. So, okay, so compared to whites.
Do we do it together? So should we do it together?
Yes, please.
Okay. So compared to whites, right? Blacks had. Go ahead.
0.7. Blacks had 0.78
times
lower
odds. Okay. So blacks had 0.78 times odds of reporting strongly favored.
No. Of reporting what?
But you said the reference category on top is strongly favored. That's why. Okay, comparison. No. Okay, of reporting somewhat disfavored compared as opposed to strongly favored. Reporting strongly favored.
And the results were
and the result was not statistically significant
Based on?
because the confidence interval contained 1.
Yes, exactly. And the p-value is bigger than?
Is greater than 0.05.
Excellent. You did excellently well.
Oh.
Okay. All right, let's look at the second table here, right? This is now neither favor nor disfavor. Now, let's pick a volunteer who will interpret the result for this female. No, let's look for one that is more than one. Asian. Let's look at the Asian row. We need a brave volunteer to interpret this for us.
Hyacinta.
Thank you. I will try.
Awesome.
Okay, I'll say Asians compared to white have 1.05 times higher odds of strong favor. And
no, of reporting what?
Of reporting strong favor. Of reporting to strongly favor the banning of smoke.
Look at the table here. Look at the way I'm pointing here, right? The comparison is what?
Neither.
Yeah.
Neither favor.
Neither favor nor disfavoring, as
Neither
opposed to strong favor, right? Exactly.
Yes.
And the result where
not significantly, not statistical significant due to confidence interval, which is higher than 1. It's 1 and above, and the p-value is greater than 0.05. Yeah.
Excellent job. That's the term. So the confidence interval is not that it's higher than 1, but that it contains 1.
Thank you.
Right. You did well.
So happy.
Right. Okay, we need somebody to interpret this Asian, but for this comparison here. Who wants to take that?
Hello?
Yes.
Okay. From the result, Asians compared to whites, right? Asians compared to whites have 1.05 times higher odds of somewhat favoring menthol ban versus strongly favor. And I said, and it's not statistically significant because the confidence interval contains 1, and the p-value is greater than 0.25.
Awesome. So you see, this is how you guys are rock stars. So this is how we interpret the multinomial regression. So remember, binary logistic regression, 1 output. Multinomial logistic regression analysis, k-1 output, where k is the number of categories, right? So here we had 5 categories. So that's why we have 4 outputs. 1, 2, 3, and 4, the one that we have not displayed because of space, right? Or you can just pretend that we collapse 2 together. All right. So multinomial regression will have k-1, where k is the number of categories in the outcome of interest. Now let's look at ordinal. Ordinal, again, remember we either go up the ladder or down the ladder. Again, ordinal will have 1 output, right? Because remember that we're looking, the assumption here is that proportional odds. Step 1 of a ladder to step 2 is the same as step 2 to step 3. So you don't need to have separate outputs. That's the mathematical basis for it having just 1 particular table output. So remember, we're moving up the ladder now. So we need somebody who interprets this black category for us in the context of ordinal logistic regression with ascending odds.
Tony, are you still, is that a new hand? No, it's been up for a while.
This only Toyina is in this class.
He has lowered it. It seems we have like 2-3 people. Let me try someone new. Chidera. Sorry,
thank you.
Nick.
So compared to being white, being black has a 0.95 times lower likelihood of reporting increasing favorability to menthol cigarette smoking. And this is not statistically significant as the confidence interval does not contain 1, and the p-value is greater than 0.05.
You use the taboo word though. You said had 0.95 times lower likelihood. Do you want to correct yourself?
Lower odds. Thank you very much. So let me go again.
Lower odds of reporting what?
Lower odds of reporting increasing favorability of towards menthol cigarette smoking.
That's a very key word you use there, right? Because we're saying we are going up the ladder. We are going up and up. We're increasing on the ladder. So they have 0.95 times lower odds of reporting increasing. The key word is increasing favorability, right? So we're saying from step 1 to step 2, or from step 2 to step 3, the favorability is an increasing level. Why? Because we're going ascending. While it's ascending, we're going up the ladder, right? Now let's now take that same mindset and come back to descending. So who wants to interpret black for us in the context of descending odds ratios? It has to be somebody who has not answered before.
I'm checking, but it seems.
And if somebody, I would choose somebody like the military chooses volunteers. Like you are all volunteers. So let's see. I'm just going to pick a random person, and you have to be a good sport and give it a try. All right. Let's see. How come I'm seeing my name on Israel Agako? No, that's Gaka. Mrs. Abdurrashid. Aminat. Do you want to give it a try? It's like, why me? Okay, maybe not. Gloria Igwe. You want to give it a try? Okay, somebody who has not spoken should just volunteer and save us out of this predicament. Wait,
Dr. Mustafa.
Okay, great.
Oh. Okay. We have Bolaji.
All right, please go ahead.
Okay. For the black, as taking the white as a reference, as 1.05 odds of visibility in a descending order. Am I correct?
Okay.
But contain a confidence interval of 1.
Okay.
Which is can significantly not significantly because it is greater than 0.05.
Excellent. That's a very solid attempt. We appreciate your answer. Does anybody also want to rephrase that same thing in another light? Thanks very much for that attempt. That's very brave and very, very solid answer. So we need another person who has not answered, who has not spoken to answer, give us their own perspective on that.
Ernest.
Can I try?
Please go
Let's
ahead.
try Ernest
Yes,
first.
so compared to whites,
Yes.
the blacks have 1.05 lower odds of being reporting to menthol cigarette smoking, and the result has statistically not significant because the confidence interval has 1.
Okay.
And the p-value is more than 0.
That's a nice attempt, but certain elements where you got most of the elements right. The two that were missing were the direction of the results, and you also did not clearly articulate what the outcome was. So you did not really contextualize that this is an ordinal logistic regression in a descending direction. So, but that's what you please, so you can work on that. Can somebody else now take what he said and build on that and then correct those two things that were wrong?
Evaristus.
All right. Compared to whites, the black, can you hear me?
We can hear you clearly, yes.
All right. Compared to whites, the black has 1.05 higher odd, 1.05 times higher odd of not favoring the ban of menthol cigarettes. And this result is not significantly different since the P level is greater than 0.05.
Okay. You are almost correct. The only thing is that you guys are failing to ignore, you're completely ignoring the context of ordinal logistic regression. You're saying that the blacks had X times higher odds of reporting support, but you have, remember, we're going up the ladder or down the ladder. You have to show that direction of the support or non-support. That is what is missing in this. So you have to.
It's lower odds.
No. This is the answer. This is higher odds, right? 1.05 times higher odds. So the odds itself is higher. But what did you miss? Are we going up the ladder or down the ladder here? We're going down the ladder, right? So they have 1.05 times higher odds of what?
Ordinal logistics.
So if you're going down the ladder, right, are we saying, are they supporting, are we indicating increasing support for bans or decreasing support for bans?
Support for the ban.
Sorry?
Decreasing support.
Exactly. So your answer must explicitly capture the direction. Are we talking about increasing support or decreasing support, right? Tell us whether you are going up the ladder or down the ladder. So now, can you take all of that and correct that expression, that sentence here?
Okay. Compared to the white, the black 1.05 times higher odds of supporting
Okay, your line is breaking. Yeah. I had up to 1.05 times higher odds. I didn't hear what followed after that. Okay, I think your line is really bad. Can somebody support him? I think he's on the right track, but can somebody finish it up for him?
Akwaza. Akwaza Kernan.
Hello, thank you, Prof. Can you hear me?
Clearly.
Okay, so let me give it a try.
Okay.
Compared to whites, blacks have 1.05 times higher odds of reporting decreasing favorability to menthol cigarette use.
No bans.
And the result is not statistically significant given that it contains the 95% confidence interval contains 1 and the p-value is greater than 0.05.
Excellent. You did it perfectly well. So can somebody now report? Let's look at another one here. Let's look at this one, Asian. Who wants to take, so that we want to make sure that we are all on the same page? Who wants to report the value for the word Asian?
Can I still report?
No, you got it perfectly. So let's have somebody else.
Joshua. Joshua.
Okay. So for the Asian, compared to white, Asians are 0.92 lower, 11.92 times lower odds of 0.92 lower odds of being 0.92 lower odds of descending order of, I think I'm getting confused here.
Okay. Are you going up the ladder or down the ladder?
Down the ladder.
So if you are going down the ladder, are you increasing support or decreasing support?
Decreasing support. Okay, so 0.92 times lower odd of decreasing support in favoring the ban for smoking. And it's not statistically significant as the odds ratio contain 1 and the p-value is greater than 0.05.
Okay, so you said it elegantly. So we can say that, like you said, Asians had 0.92 times lower odds compared to whites of reporting lower support. Because we're going down the ladder of reporting lower support for menthol ban, right? And that result was not significant. If we want to express it in terms of relative way, instead of saying 0.92 times, and by the way, most of you have started to swallow that times. Please always say it when you're going to say the number accurately like that, always insert the word times. 0.92 times lower odds. We want somebody to express it in terms of a relative odds, right? In terms of percentage of saying like 8%, can somebody express the result for Asians in that context relatively?
Omar, did you answer before? Omar? Christine?
I try.
Okay, Davis.
Okay, thank you. So blacks compared to whites have 5% increase odds of reporting probability of reduced favoring tobacco ban, though the statistical significance is not.
Okay. All righty. We have to go and practice, okay? So please go and practice. You can say 5% higher, odds of reporting lower support, because we're going down the ladder for menthol bans, right? So again, please practice. That's how you get it right. So let's quickly we're done with this session. So let's quickly show you how to calculate the sample size. for when we have this, let's call that a day. So quickly log into the chi-squares platform to just quickly show you the last part of the session, which is how we calculate sample size for an ordinal logistic model, if that's what we're trying to collect data for. Let's log in here. I assume everybody has access to the chi-squares platform at this point. If not, Lungile will drop a link to show you how to access that. So as usual, we'll go to sample size. We'll start new sample size. Let's say we're doing a cross-sectional study. We will select percent mean as the outcome, right? But remember that when we calculate sample size for the mean, we will consistently get smaller sample sizes, right? So if that's what we want, that's great. In which case, we'll provide the standard deviation of the mean, whatever that standard deviation is. I don't know what it is. It depends on the outcome. You provide the population size. You indicate whether cluster sampling will be performed or not. You provide a margin of error and anticipated response rates. And based on that, you're going to get a sample size, right? You know, that will of course be dependent on the standard deviation, right? So you have to make sure you get a standard deviation right. Because that would obviously affect a very wide standard deviation means that there's a lot of variance in the outcome, and so the sample size will be very large. So that is how you could calculate that. If you don't know what the standard deviation is, we have a shortcut here for you. This is a rule of thumb, right? If standard deviation is unknown, estimated using the range rule of thumb. This rule of thumb suggests that the standard deviation is approximately equal to 1/4 of the range, or you can take the highest value minus the lowest value and divide by 4. So if we're looking at the scale, for example, that has the highest value on the scale is 5 and the lowest value is 1. So 5 minus 1 is 4. 4 divided by 4 is 1, right? That is just a rule of thumb. Of course, the rule of thumb is that there's no rule of thumb, but that gives you an approximate way of estimating sample size if you don't know what the standard deviation is. But you can try and supply the exact value to get more precise results. But as we said, if you're not sure what to use and to become more conservative, you can use categorical outcomes, because the sample size for a categorical outcome will be more than what you will require for the equivalent continuous outcome. And in this case, you provide these parameters here, including the prevalence of the outcome. If you don't know what the prevalence of the outcome is, you can always enter 50. 50 is the prevalence at which you have the maximum variance in the categorical outcome. And that guarantees you that the sample size will be the maximum, so that you are always covered. The point here is always acting from the worst case scenario. And so that once you get a sample size, you can then use that for your study to collect the outcome of interest. So that's how you could calculate your sample size for a study in which you're going to do an ordinal logistic regression. All right, that's the end of our class. I don't know if you have questions. The last slide is just showing you alternatives to logistic regression, that we can choose to collapse the variables into 2 and then do a binary logistic regression if we wanted. Or we can use a multinomial logistic regression if we can argue that, well, they are not ordered. But of course, if they are truly ordered, then we lose information from the fact that we already had an ordered variable and we've decided to discard all of that order. But yeah, that's the end of our class. If there are any questions, I'll take them now.
So before we take questions, once again, I just want to request, while most of you are still here, please do help us with our marketing. We will receive certificates over the weekend. Please post, tag us. We will really appreciate that. I mean, we have over 100 people each time, but like 5 people posting. So maybe some of you were waiting for the last session, which is today. So we hope after the session, we will see something. Some celebration, those things that they have on LinkedIn, preferably certificates, but, we can't force it. So please do something. It really helps us with our marketing, and that's all we ask of you. So, okay, we have questions. I'll start with Oscar. And please wait, wait for me to call out your name before, just for control reasons. Thanks.
Yeah, Prof, thank you very much for today's lesson. So when you are running the ordinal regression, does it make room for adjusted and unadjusted ratios?
Yes. So whenever you have adjusted, simply means that you have more than one variable in the model.
Yes, please.
So this is adjusted because you have age, race, gender, and tobacco use. If you only had age, that would be an unadjusted model because there's only one variable in the model. So whenever you have only one variable in the model, it's crude or unadjusted because it's just bivariate. You only have the outcome and that one predictor. Once you have more than one predictor variables in the model, automatically that means it's the same thing as saying it's adjusted. Does that make sense to you?
Yes, please. My last question is, I'm running a similar, as if today's lesson is meant for me. When I calculated using the adjusted OR ratio, I had a confidence interval between 0.18 to about 62,179.32.
Oh, wow.
So should I leave it as it is or I should manipulate it?
Well, first of all, do not manipulate anything. Secondly, it tells you that the sample size is very small, right?
Oh, okay.
And so that is a problem there. So you might want to reassess that particular outcome. So maybe you have a lot of missing values as well. Remember that when you do any regression, the software does list-wise deletion, which means that individuals with missing values for any of the variables are removed from the analysis. So the key issue here now is for you to reassess whether that data set is fit for use. Not every data set can be used for analysis, and not every data set can be used for a particular analysis. So sometimes you might want to look at, okay, this outcome is associated with too many missing values, and that's why I'm having these wide confidence intervals. Can I use another outcome? And if I cannot, then maybe can I even use this data set at all? Because it's kind of very ridiculous. Having that kind of wide confidence intervals, like it just looks ridiculous. So those are things that you want to explore. You want to look at the quality of the data. So this is that wide confidence interval is telling you that you have issues with data quality. So it's now time for you to go and inspect the data carefully to see issues of quality of data, issues of missing values, and what that means for you as far as your research question. Should you even go ahead with that same research question, or should you look for another outcome? But yeah, those are some of the decisions that you have to explore with that data set.
Okay. Thank you very much, sir. I'm grateful.
Oh, you're welcome. Yes. All right. Any other questions?
Diego, hi, Center.
Yeah, thank you very much for the opportunity. I always enjoy your class. I don't know whether you've mentioned this already and then it escaped me, but when you are reporting the odds ratio, is it okay? Maybe we didn't include it here, so maybe that means it's not okay, but is it okay to include the standard deviation or standard error? If you can include it at any time, which of the two is allowed? Thank you.
So what we're trying to measure here is the variance. The variance is simply the how wide, all of those terms, right? So think of terms like standard error or confidence interval. They're all telling us one thing. They're telling us with what uncertainty was this point estimate measured. They're all trying to give us, they're all saying the same thing in different ways. However, for reporting, standard reporting, we choose to go with confidence intervals, and this is governed by rules. The way we do things in science is governed by rules. So for example, rules that guide how we report things in research are governed by STROBE. So please make some time to read up on STROBE, STROBE guidelines. STROBE is strengthening of reporting of epidemiology, right? And so STROBE guidelines, for example, let me drop the link here. The PDF, let me see if I can pull it up.
Hello, sir.
Yes.
Yes, thank you, Prof. Sir. I've heard a lot, learned a lot about
If you
the
can hold on,
discussion.
if you can hold on for a second, let me just quickly round up to the answer to the previous gentleman.
Yes, sir.
Yeah, just hold that thought. So, so this is STROBE guideline for reporting of studies in epidemiology. And so if you look at the results, STROBE requires that you give unadjusted estimates, and if applicable, confounded adjusted estimates, and their precision, like the 95% confidence interval, right? And so again, it's even STROBE doesn't require you to say, this is just as an example, they say confidence intervals. Traditionally, we've always measured uncertainty with confidence intervals. But the rule of thumb is that there's no rule of thumb, right? You can choose to report it however you want, but conventionally, we've always used confidence intervals. So yes, if you're going to make it easier for editors and for reviewers to read your paper and provide feedback, then you just have to follow the standard conventional way of doing it as recommended by STROBE, which is usage of confidence intervals. I hope that answers your question. All right, I'm going to drop the STROBE guidelines here for you. All right, please go ahead. You asked me a question.
No, I said I would call out names, so please.
Okay, sorry.
Yeah.
All right, go ahead. Sorry.
Hyacinth, it was your turn actually, before someone asked.
Okay, you're not allowing me. Okay, thank you. Thank you, Prof. Greetings from Tanzania. Yeah, so I'm very, very new in this subject matter. So yeah, I was so encouraged to hear people don't understand because they were speaking my reality, and that encouraged me to continue being in the class. I have a question. Number one, you gave us an example on confidence interval, and you were telling us the range between, we say like, which one is wider, 95 or 99, and then we say 99. And then you say like, so to be in a safe side, it's good to go lower so that you're not running the risk of including one. So in that situation, we said 95 could be an ideal answer. So now I'm just thinking like, so for instance, if I've been given option to choose between confidence interval of 85% to 95%, will I be in a safe side to choose 85%? In assumption of the argument you gave before? That is one question. Second question is about statistical significant. This time I understand it very well when you use the example of the ladder, and this is what I understand. So I just want you to confirm if my understanding is correct. So when we say something is not statistically significant, we mean the data were not that much many, like there was a small sample size. Is that the like every time when I hear not statistic significant, is that what they communicate, like the sample size is not that much huge? And the last question is on the ordinal logistic. When you were doing when we are doing this testing, like a translation, you said there's two things of the going up or going down, that is increasing and decreasing. And then when we're translating the last example that you have given us of the black men versus white, we were trying both way, like trying going up the ladder, which is increasing, and going down the ladder, which is decreasing. I'm a little bit confused with the thing with going up the ladder. That means with going down the ladder, that means decreasing. Because with the example, when I was following up, I realized we translate the number the same, and the only thing that changes the word increase or decrease. So in my thinking, I was thinking if something is decreasing, then maybe the odd ratio, we have to minus 1 from the odd ratio so that we say this is something decreasing. But in this situation, it wasn't the same. We were just saying, like, we're just translating the same, and we only change increasing and decreasing word. And to me, it really didn't make sense. Thank you so much.
All right, great. This is a great question. So, oh, geez, I forgot to take notes when you were talking. So, if I forget, you have to remind me. The first question, I forgot the first question already. The first question was, oh, geez, please help Lungile. What was the first question? I am so sorry.
The first question was confidence interval, 85 and 95.
Oh, okay, yes, I remember. Yes. So, okay. This confidence interval is not a menu where you can choose which one you want to use. You can't say, oh, you know what, me, I like to use 75% confidence intervals. So they are part of scientific norms. Norms means it's not as if it's a rule set in stone, but that is how we do things in general. In general, we always use 95% confidence intervals. So does that mean that it was sent to us by God? No. What does that mean? It means that this is what we have chosen to traditionally, again, what is traditionally or conventionally used. So please don't, the take-home message is not that you choose that, oh, I want to work with 75% intervals or I want to work with 85. No, you should use 95% confidence intervals for the most of your work, right? Unless when a reviewer or an editor-in-chief says that, well, I'll prefer you use 99% intervals, and they will provide the justification for it, right? So that is how so the take-home message is, please always use 95% confidence intervals, because that is how we as scientists have traditionally reported or done research. That's the convention. Convention means that it's not a hard set rule, but it's just the way we do things. Does that answer that part of your question? Before I move to the next part. Okay, I'll take silence as consent. The second part of the question was about what does this statistical significance mean? So your understanding of it is wrong. You understand statistical significance means that you think it has to do with sample size. That is a wrong interpretation of it. First of all, we only talk about statistical significance when we're comparing two things, right? So whenever you think of statistical significance, always think of it in your mind that we're comparing two things, right? So when we say that, so let me step back and create a new slide here. And let's call this hypothesis testing. So whenever we're testing simply means we're comparing something, right? Comparing two things, A and B, A versus B. So the question is, are these things the same or are they not the same? That's all we're asking. Is A and B, are A and B the same or are A and B different? That's the only question we're trying to examine, right? So it's either A is equal to B, that's the only option we have, right? Or A is not equal to B, right? Or A is not equal to B. These are the only two options. It's either A and B are equal or they're not equal. So we call this the null hypothesis. Null hypothesis means that, well, this is the boring hypothesis that, well, nothing interesting is happening here, right? And the alternative to the null is called the alternative hypothesis, right? So when we are doing hypothesis testing, when we say a result is statistically significant, it means that we're agreeing with this alternative. We are saying that indeed, these two guys are different from each other. When we say that something is not statistically significant, we are saying that, well, we are sticking with the null hypothesis. This is as simply as I can frame it, right? So don't relate significance or non-significance to sample size. Relate it to hypothesis testing, whether we're saying, are these two things different or are they not different? So when we say something is statistically significant, we mean that we are saying that they are different from each other. So I hope that answers that second part of the question. The third part of the question, okay, great. The third part of the question has to do with this ascending or descending. So that has nothing to do with subtraction of any value from 1, right? So completely remove your mind from that. The odds ratio, the table remains exactly as the table is. What changes is, are we going up the ladder or down the ladder? So let's say that we're interpreting this. Let's say I'm also going to take the same value here now, and let's interpret it the same way. And remember, what determines how we interpret it as up the ladder or down the ladder? Well, it is when we are fitting the regression model, right? Let's go back to this here. When we are fitting our regression model, we have to select whether the direction we want to interpret the result is ascending direction or descending direction. So when you make the selection and you say that I want to interpret the result in an ascending direction, you have already decided that, well, this is how I want to see how the outcome increases as the predictor increases. So the issue here is an issue of interpretation. It has nothing to do with changing the table. The results will come out here and you don't have to change anything yourself. All you have to do is to change how you're interpreting the results. So when we are interpreting in an ascending way, we're saying that for this one, for example, the odds of compared to, among blacks compared to white, the odds of reporting increasing support. Why is it increasing? Because we are going ascending. Why did we choose ascending? Well, because we selected that we want to interpret the results in an ascending way. So the calculation is done automatically in the back end already, and the results you are given already accounts for the direction of the results. So you don't have to now start subtracting anything. The result is already been calculated for you that way because you chose the result as ascending, right? By the way, what happens in the computer is that when you say it's ascending, it ranks it from the low to up. When you say it's ascending, it just flips that order automatically on the other way around and feeds it to the same machine. That's what the computer is doing behind. So if you have low, moderate, high as ascending, when you select the descending option, the computer will just send it as high, moderate, low. That's all it's doing. It's nothing complicated, right? It simply inverts the vector and sends it the other direction, right? And so the interpretation has to change too. The result obviously will change because we're looking at the vector in a different direction. But essentially, if we're going to interpret the black, it's going to be say that the odds of reporting or blacks had 0.95 times lower odds of reporting increasing support for bans on menthol use compared to whites. Assuming that this same result was sent in a descending direction, it doesn't change. We're still going to say blacks had 0.95 times lower odds than whites, but this time we'll say of reporting lower support. So the only thing that's changing is, are we going up the ladder or down the ladder? Are we saying increasing support or are we saying decreasing support? That's the only thing that changes. So the direction in an ordinal logistic regression is just so we can frame the results in the direction we want, whether it's ascending direction or descending direction. Does that answer your question?
Yes, but there, before you remove this table, I understand what you said, but I am thinking, let's look at this black and let's look on confidential interval. So,
okay.
So my understanding was, if I see the confidential interval is going up, let's say 0.76 to 1.20, that means this is ascending, like it is increasing. So I was thinking, by looking at it, I will know like, okay, this particular person has calculated this data and this is in ascending order. But if it goes 1.20 to 0.76, I would say this is descending order. I don't know if that's thank you.
I see where the confusion is coming from. So you are saying, let me make sure I understand you very well. You are saying that you look at this odds ratio, this confidence interval, like here is increasing. So that is telling you that it's increasing.
Yes.
Oh, okay. No, don't look at the odds ratio. Don't look at the confidence interval at all. Just completely blind your eye to this confidence. This is only to tell you whether this result is statistically significant. So please, the goal is not to interpret this confidence interval in an ascending way or descending. Only look at this confidence interval to tell you whether this result you have seen here is significant. So again, this has nothing to do with the direction of the ordinal regression, right? this is the only use this is 7 is to tell you whether this result you have observed is statistically significant or not. So we will look at this number. We're going to say blacks at 0.95 times lower odds. Why is it lower? Because it's less than 1 compared to whites of reporting increasing. Why is it increasing? Because it's ascending. It's ascending based on here, not based on here. It's based on how we selected it as ascending, right? This has nothing to do with whether it was ascending or descending. So blacks had 0.95 times lower odds compared to white of reporting increasing support for ban on menthol cigarettes. But now this is where we'll come back to this one. But the results were not statistically significant, judging that this confidence intervals included 1. Do you understand now?
Yes. I really understand. And now I see like from the title, they say it's already ascending, right? So that means my translation has to follow the order of ascending.
Exactly.
And if it is decreasing, then they would say up there that this is a decreasing, and then my translation has to do decreasing. So so I assume the odd ratio, if it is decreasing, the real one, maybe the number will change. That is my thing.
So exactly, yeah. So this the odds ratios will change, obviously, yes, because we're inverting it now. All these numbers here are hypothetical numbers that just entered. They don't come from real data. They're just meant to provide instruction. So, but yes, the results will change. Like even here, even with the dummy data, you can see that this was 0.95. Now this is 1.05. It has changed in the direction as well. But that's what you will expect. Does that answer your question?
Thank you. Thank you very much.
Oh, you're welcome. Any other questions?
Yes, we'll take Mohammed.
Thank you so much. Thank you for the presentation, Prof. I just wanted to know, I've been doing some work on gamma Poisson regression. So there's what we call, is there any difference between credible interval and confidence interval? Because somehow the interpretation in that case, they make more emphasis on your value, that is your interval, having 0. Why I can see in this case now, our target is looking at the value having 1. So I wanted to know. Then regarding if you have variables, you need to make a reference value. Is there anything that you really that you need to consider in making that choice? Maybe for like age, maybe you categorize getting into young and adult, and you wanted to fix a reference value maybe for the adults. Is there any particular rationale behind making those selection? Thank you.
Right, thanks. For your first question, we've already put we've already answered that question extensively on our LinkedIn post. So you can just please go on our LinkedIn post and read it. That will provide you more.
I'll do that.
So let me drop the link for you. I believe, let's see if I can find it here. I believe we had a post on this. So let me misclassification. Difference between credible intervals and confidence. So so please just go and read it so that we don't answer the same question twice. Oops, how do I click that link? Lungile, please, if you can just pull that out and share with the folks, that would be great. The second part was what governs the choice of, like, why did we choose white as reference group? Why not black? Why not Hispanic? That's your question, right?
Yeah.
So one is, again, based on convention. Convention doesn't, again, it's not as if it was given to us by God, but that's just how it's done in other studies. And you don't want to create a study where your study is just a silo and you cannot compare your studies. If all other studies have used white as a reference group and you want to really compare your study with other studies, then you really have no choice, right? It's easier then to use white as a reference in that context for comparability. So that's what one of the considerations. The other consideration is just interpretability. Like if interpretability from the context of disparities. In general, when we're looking at disparities, there are guidelines for what comparisons or benchmarks we use. We always try, for example, to compare to the most disadvantaged group. So if we're looking at, for example, our outcome is some access to care, and we're looking at, for example, let's say income. The most disadvantaged is people who have the poorest, right? So from an equity perspective, it makes sense to use the most disadvantaged as a reference group, right? So you can, in that case, you see that, wow, people who had high income had 10 times, access to care compared to those who were the poor. And then we can now say, oh, wow, these people are really, really disadvantaged. So from an equity perspective, sometimes we use the most disadvantaged group as a reference group. Now, statistically, if you don't know, if you have a choice to look at whether just the statistical issues, you might want to use the group with the largest sample size as a reference. So if you don't care so much about issues of equity, and you don't care so much about issues of comparability, and you don't care so much about issues of conventions, you just want to pick a reference group based on statistical reasons, then you want to go with the group with the largest sample size, because then that makes the confidence intervals less wider. The estimates are much more precise with that reference group that is the biggest. So again, it depends on a case-by-case basis. What might work in one scenario might be a completely different indication for another scenario. So you are the one who is doing the study. So you best know the context in which the study is being done. But those are some broad general principles that can guide you in determining which to use as a reference group. Does that make sense?
Yes, sir.
Right,
Then, okay, I don't know, maybe lastly, you did a study and maybe from your result, you are getting that, okay, the validity, you have a problem with the validity because of your sample sizes maybe small. Is there any way around that statistically, or maybe writing a model or something?
And that's medicine after death. So you have to go and, like that. So the issue of validity that are concerned here is what we call a type 2 error. Type 2 error is when you have a result that is non-significant, all right, in your study, even though in nature it's significant. And the reason for that is studies are underpowered. So maybe your sample size that needed was 5,000 people and you have 2,000 people. The most common reasons why you have type 2 error in studies sometimes is because you have subgroup analysis. So sample size, remember that the sample size calculation was done for the overall study.
Yes.
That you now want to do a whole bunch of subgroup analysis. So in that case, there's a solution. The solution is stop doing subgroup analysis and just focus on the primary, on the primary analysis, which was for the whole population. If you must do subgroup analysis, just do and interpret them qualitatively. Don't now start saying, oh, this group was significantly. That is just a travesty of statistics, because you are now just committing offenses against data, in doing comparisons that are not powered. So, so again, just be prudent in your use of subgroup analysis. If you're going to do subgroup analysis, those should have been determined a priori in your protocol. It's not that you're now just going on the fly and saying, this analysis in the main analysis is not even significant. I now want to fish for a p-value. I'm just going to start doing all this subgroup analysis until I find the one that is significant. That is very immoral. That should not be done.
Thank you so much.
Welcome.
Rosemary.
All right, thank you so much. Thank you so much, Prof. Thank you to the organizers for this wonderful training. Rosemary from Nigeria. Firstly, I want to say thank you. It's been really draining. I could imagine how it is for you for over 3 hours talking, and then people go back and forth. And I see your tolerance, and I really appreciate how you tackle them. Okay, so my question is, just on this regression, just on this page you're presenting right now, we are having a reference group of white and then black and Hispanic. What guides you to know which one to compare? Like, do you have to start specifying that blacks are 1.06 odds ratio higher? That's so. And then you also talk of Hispanic, and then you also talk of Asian, or do you just focus on one? And what makes you focus on one? Could it be because there is statistical significance? Could that be the reason why you want to focus on one? And my second question is just, I think you were able to answer it with the last comment you made. Why doing it quantitative? Why not just do qualitative? Like you have an odd ratio, sorry, you have a confidence interval of about 6,000 something from the first person that asked the question. The sample size already is saying that it's very small, and then you can't start doing regression. Why not just make it qualitative? I think that answers it. Because in my mind, I'm like, you've done a research proposal, you've stated what your outcomes are, your predictors and all that. And then you call all of a sudden, because of what your model has said, you want to change it. It may be very hard to change because it's been put into your proposal. This is what you want to do. So what I'm asking, should you just discard what you've done so far, or would you just, because I'm thinking in the line of you've done a research proposal, so you stated exactly what you want to do. So should you just discard the efforts, or what next? Thank you.
So that's a very good question. So your first question was, how do you determine what to report? Initially, I thought you were asking about how do you determine the choice of a reference group, but I am assuming, I just want to clarify that you're actually asking for, how do you determine which of this, all these answers, what do you report on? Is that your question? Okay, I'm going to answer that question because we already answered the previous one on how to select.
I'm sorry, Rosemary, please confirm.
Yeah, thank you. Yeah, I'm on you. Yes. So I was asking not the reference group now. What do you across the other variables? What do you compare with the reference group? Exactly what, like Black, Hispanic, Asian.
Okay. So the comparison for reference to the reference group must be within that group. So in this case, so we're going to report it variable by variable. So in this case, we're going to take age. So when you're reporting, please in your manuscript, do not report results for intercept. Even if you're reporting the table, because it has no real world intuitive implications. So intercept is in your table, sure, but don't report it in the manuscript. For age, so then the rest variables, we're going to take it variable by variable. The principles here are, we want to focus on only results that are significant. There's really no point beating results to death that are not significant, because the absence of evidence is not evidence of absence. So the fact that results are not significant doesn't mean that in reality they're not significant. It could just mean that you don't have enough sample size. So in general, we tend to focus only on results that are significant. So that means that in this whole table, I would say that there was no significant association between support for bands and any of the explored variables, full stop. One sentence will summarize all this table, because as you can see, none of the results are statistically significant. So there is no point taking age and saying age had blah, 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 and p-value was this, when the results are not significant. So the entire result of this table will be summarized in one sentence. None of the variables assessed, that is age, race, gender, and tobacco use, were significantly associated with support for bans on tobacco use, full stop, right? I will not go into detail with each single row because none of them is significant, right? Now, if the results were significant, let's see the one that was significant. Well, I can't see anything that was significant here, but assume that some of them were significant. When you take variable by variable, you will just focus on the ones that were significant, and you will compare to the reference group for just that variable. So variable race here has, Black, Hispanic, Asian, and other. And as far as I'm talking about race, the comparison will be in relation to whites. If I'm talking about gender, the comparison will be in relation to males. Why is males the reference? Because I chose it as a reference, right? I could have used female, but in the case of this analysis, I used males. So the comparisons will be in relation to males. For tobacco use, I'll use, never use us as a reference group because that's how I did it. But so the interpretation is in relation to the reference group for that particular variable. And, and it's, you will focus on results that are significant because, like I said earlier, absence of evidence is not evidence of absence. So, so that's the principle there. For the second part of your question, which was you've written a proposal and you've come out with a date with a study plan and collected the data, and then you see confidence intervals that range from 1 to 1 million for your regression. What do you do? Well, you have collected the money for the grant, you've collected data. You can now say, well, we have nothing to report. But it's obvious, like day, that your sample size is not enough for any regression analysis. So in that case, you should just focus on descriptive analysis. So you can still say that from a data set, 50% of adults supported bans on tobacco use, and prevalence was higher among males, females, prevalence was X% among this and that. Descriptive analysis are still important. It's not until regression enters your manuscript that your paper is gold. It's more responsible behavior to ask of the data only what the data can provide, right? So in that kind of scenario, it's just focus on descriptive analysis, which is what you can do with the data, and just stating your limitations that in this analysis, we can only perform descriptive analysis because sample sizes were too small for formal hypothesis testing. And this is something we can address in the future grant or in the future study. So just do what the data can support and just leave the rest. So that's what you could do in that kind of scenario. Okay, next question.
Gideon.
Okay, thank you very much, Prof, for the presentation. So I don't know, I think maybe the answer you just gave now might be my answer to what I actually wanted to ask. So okay, so I wanted to ask in logistic regression, whereby you have a group, okay, let's say BMI, you have normal weight, underweight, probably overweight and obesity. And by the time you want to run the regression, you find out that one of the group, let's say underweight, one of the group has, let's say, 0 value, but others are completely complete and they're okay. By the time you put that in logistic, it doesn't give you a result, probably give you 0, 0 on the confidence interval. So in such a situation, what do? You have other values, they are okay, but probably just one group might not have had someone who had that particular group, or yeah. So what do you do in such a situation? Should you just do away with that particular group, let's say BMI or category or variables, and move on with others? Or is there any way you can adjust? Because in such a situation, you cannot regroup it again, since you cannot regroup underweight as overweight. There's nothing you can do about that. So what can one do in such a situation? Thank you very much.
Yeah, so in that case, your study has violated a basic assumption of modeling, or especially in context of causal inferences, what we call positivity. Positivity is an assumption that requires that every subgroup has a positive and non-zero probability of observing the outcome. So in other words, right, if you take any subgroup in your data, like in your example here, underweight, we should be able to calculate the probability of the outcome in every and each single subgroup that exists in your study, right? So among underweight, for example, what is the probability of the outcome? Well, that means that we are going to have the number at the top and number at the bottom for you to calculate probability. In your case, you either don't have a number at the top or the number at the bottom. So you have violated the assumption of positivity. And so what can you do in that case? Well, you can see whether you can collapse some groups together. So in this case, you have, let's say, underweight, and you have, normal weight, and you have obese. Perhaps you want to look at groups like obese or non-obese. it is smaller, of course it's cruder because you are losing some information, but it's always one of these trade-offs between precision and validity. It's more valid to have a lot of groups like, underweight and normal weight and overweight and obese and morbidly obese. That allows you to control for confounding within those levels. That is valid. But trade-off is precision. Precision is always a trade-off for validity. So in this case, the more groups, the less precise, because the sample size within each group becomes smaller and smaller or none at all. So how do we address this trade-off? Well, sometimes you have to lose validity to get precision. So in that case, you might have to collapse into two groups like obese or non-obese. You have obviously lost some validity there, but you've gained precision, and you've met that assumption of positivity, because now in each group you have positivity, because you can calculate the probability, which is non-zero for every subgroup. So that's one way you can. So it's all, life is all about trade-off. So you realize that, okay, in this case, what kind of trade-offs are we dealing with? And you can also explore whether there are other variables that you could use that are perhaps collinear with BMI that you could use instead of BMI in your model. So that's one other option you could explore. All right, next question.
All right. Allow me to read from the chat box, and then I'll get back to Daniel. What are the recommended established statistical models that can be used to predict mass drug administration endpoints for hookworm infection, which is binary, infected coded as 1 and not infected coded as 0?
Well, that's it's binary outcome. Well, the very topic of what we're discussing, binary logistic regression. You can use binary logistic regression. You can also calculate. Generally, when you have an outcome, it also depends on how prevalent the outcome is. For outcomes that are prevalent, and by prevalent, highly prevalent, we mean, or very common, we mean outcomes that are 10% or more in the population. You will find that logistic regression overestimates the likelihood of the event. So if we're using the odds ratio as a proxy for the relative risk, you find that consistently the odds ratio will always overestimate the risk ratio. So if the outcome is common, you might want to calculate prevalence ratios instead. So prevalence ratios are very conservative and are more approximating to the relative risk. So you have a lot of options. You can calculate probabilities with the probit model. You can calculate odds ratios in a binary logistic regression model. You can calculate prevalence ratios in a Poisson model with an outcome of 0 and 1, right? And ultimately, the choice will be determined by how prevalent the outcome is. If it's a common outcome, then you might want to use prevalence ratios. If it's a rare outcome, well, it doesn't matter, because if it's rare, the odds ratios will approximate the relative risk or the prevalence ratios anyway. I hope that is clear.
Thanks, Doctor. Daniel. Daniel Onusulu.
Okay, thank you very much for the opportunity given me. And thank you once more, Professor Gaku, for your wonderful lecture. I just want to clarify something. What is the difference between alternative hypothesis and research hypothesis?
Okay. So the alternative, so let's go back to the previous slide. Did you follow up? Okay, let's do this. Do you have a research question in mind? So that it doesn't look abstract. Do you have a research question in mind that you are trying to explore these issues with?
None readily comes to mind now.
Okay, I'll make up something then. So, so let's say our research question is that association, the research topic. Topic is, our research idea is I'm drawing a blank now. Association between, let's say, associations between, let's say, tobacco use and, let's say, lung cancer. Right, that's the idea. I'll have to formulate a formal research question. Right, this is not a question. This is not a research question. A question has to end with a question mark. If it does not end with a question mark, it is simply not a question. So I'll take this idea and carve a question from it. Question will say, what is association between tobacco use and lung cancer? See, this ends with a question mark. Now, this is a research question. Why? Because it ends with a question mark. So from the idea, we'll come up with a question. Now, our hypothesis. Our hypothesis is our well-informed, educated guess of the direction the study will take, right? So I mean, so from my own understanding, based on the things I've seen and the literature I've read, I can make a guess as to where I think the result will go. So I will say that smokers, my hypothesis is that smokers will have increased risk of lung cancer, right? So this is, again, my own guess. I've not done the study yet, but I have an intuition for where I think that the results would go. This is my hypothesis, right? Now, this is quite different from the study hypothesis or the hypothesis for study testing, right? So in this case, framing the null hypothesis, let's say hypothesis testing, the null is that there is no difference in risk between risk of lung cancer between smokers and non-smokers. My alternative hypothesis is that there is a difference. So this alternative now is that there is a difference in risk of lung cancer between smokers and non-smokers. So take note that from hypothesis testing, right, the null is, in general, is a declaration of no difference between the two groups. The alternative, we typically frame the alternative in a two-way direction. Two-way meaning that, well, I don't want to assume. So take note that for your own personal hypothesis as a researcher, it is directed. I'm saying that, smokers will have increased risk. The alternative in a two-way testing mode says, well, there's no difference. This is quite different from saying that smokers will have, this is a one-sided test. This is saying that I know the direction is going to go, right? The alternative simply says there's no difference in risk of lung cancer, right? So it's framed in a way that is neutral, and that is we can then confirm, is it true that there was no risk? The sample size for a two-sided test is larger, and so that allows us to test both directions. Direction here is that either smoking protects against risk of lung cancer, or smoking causes the risk, or it either increases the risk or decreases the risk. So in framing, this has to be done in a neutral way for hypothesis testing. Whereas my hypothesis for my own study as a researcher, it has to have direction, right? I can now say smokers will have increased risk of lung cancer. Does that make sense to you now?
Yes, Prof. Thank you very much.
Oh, you're welcome.
Okay, I'm going to look for another question on the chat box. So regarding subgroup analysis, how do we factor that into the sample size ahead?
All right, so if you're going to do subgroup analysis, so first of all, try to avoid indiscriminate. The fact that you can do something doesn't mean you should do something, right? So the fact that you can do all manner of subgroup analysis does not mean you should do it. In fact, because there are so many risks, that are associated with subgroup analysis, because that becomes a fishing expedition. So in general, right, if you're going to do subgroup analysis, first of all, before you even talk about sample size and data, sit down and specify why are you even doing this. And if you're going to do it, you have to specify the subgroup analysis a priori in your protocol. Now, you have now decided that, okay, you want to do this, you must do the subgroup analysis. That means that your sample size for those subgroups should be sufficient. So look at the subgroups you want to do and make sure that you have enough people in those groups to even do the sample size, to even do the study in those groups at all. Because the sample size for the overall population will be the same as this sample size in those subgroups that you are interested in, right? So that is what you need to do. So, but in general, it's if you can avoid doing subgroup analysis or indiscriminate subgroup analysis, please do so, because of the risk of type 1 error, which is you end up finding things just because you're looking so hard.
Thank you. Okay, Promise.
Hello, can you hear me?
Yes, we can.
Clearly.
Okay, thank you. I just wanted to thank you very much, Prof, for your wonderful education, and it has been quite insightful. I've not been following, but because of work related issues, but anytime I have chance, I just try to hop in, and I always enjoy that particular experience, just like today's one. So I wanted to ask, as regards it's a little bit outside what has been discussed. When you want to, I don't know if it's something I should be looking forward to, or let me just drop it there. If you want to do pooling, systematic meta-analysis, do you have to, will you be able to do this kind of logistic regression within pooled, included papers? If not, what are possible routes to handling such a case? Thank you.
Well, we're having a session on systematic reviews next 2 weeks. So I think your question will be best directed in those sessions. So maybe Lungile can also drop the link for the sessions next week, the next 2 sessions, so folks can register. So I think that, but in a nutshell, you'd want to, I think we're going to answer this question on systematic review. We're going to have a session next week anyway. So just try and register and attend those sessions.
Thanks.
Okay.
Can I ask either Michael, Elia, or Queen to help me with those links, please? Thanks. Okay, next question. How can you expatiate more on the meaning of confidence interval?
Okay. So again, the other gentleman who asked for credible intervals, we already have a well-explained page on the interpretation of confidence intervals and credible intervals. So I think you really need to just go and watch, go and read this on our page, because it's clearly explained with examples and with case studies and everything. So this is one of the things you just have to go and read, because we've already explained it very carefully, and the best practices for using credible intervals versus confidence intervals. So please just access our LinkedIn page. This post is there already, and it's well explained.
Okay.
Next question.
Micah, Ehada, Isa.
Yes. Good evening, Prof.
Hello.
Hello. Good evening, Prof.
Yeah, we can hear you clearly.
Hello. All
yes,
right,
we can hear
Prof.
you.
Sorry. Thank you for that beautiful lecture. I want to know what will be the difference between ordinal and ordered logistic relation in a nutshell, sir?
None. The same thing. Potato.
Okay. Thank you so much, Prof. I'm grateful. Thank you so much.
That's all in terms of the hands, but let me look. If you still don't have access to the chi-squares platform, please let us know. We've shared the link, the invitation link, but please just let us know again. Dr. Agaku, here's another question. How logit binomial regression different from binary logistic regression? When do you use logit binomial regression and how do you interpret it?
So, logit, I'm assuming this person is a theta user.
Yes.
Logit is just a command in theta to give you the log odds in a binary logistic regression. So again, the model is a binary logistic regression. So please, want to distinguish issues of commands. Commands are specific to software. So theta might use logic, but another software might use another word. So we're not really interested in whatever the command is. What we're really emphasizing is a core understanding of what we're trying to achieve, just from simple base principles. So if you're using, for example, R, R's code will require a syntax, part of a syntax is binomial there. So again, the point is not so much on how one programming language frames it or the other one frames it, but on what does this model even mean? What are we trying to achieve, right? From just simple basic principles. So so please review our slides. We've covered extensively all of the elements of what a binary logistic regression means and all these other regressions. So just kindly review the previous slides and try and catch up to speed on that. And also try not to be too distracted by syntax. Try to distinguish issues of core principles and basic understanding versus how they are implemented in software, which is a very different issue. Because there you have issues of all of the things we've mentioned now are just issues of syntax in different software and not necessarily related to the core fundamental issues of what we're discussing. So please catch up to what we discussed in the previous sessions on those different models.
Okay, thanks. Adebola.
Hello, good evening. From Nigeria, my name is Adebola.
Hello.
Thank you so much for this. Hello, can you hear me, please?
Clearly, yes.
Yes, thank you so much for this great opportunity. It's really, it has been helpful for me. I'm an undergraduate and studying statistics, and in fact, I really enjoy all the classes. And I so much appreciate this. Thank you so much for what you're doing. And may God bless the team. Okay, so there's something I would like to ask you. You mentioned something, I think was it the second class or the first class? Okay, when somebody was saying, I think they were talking about using different variables when you are doing model selection, like maybe I want to model like a regression model actually, and I have different covariates, and then maybe when I remove one covariate, my R square was better and all those things. And you said it's a wrong way to do it. But probably I missed maybe you talked about it again. And I'm trying to ask if there's a material. I think I know the time is up. And maybe there's a way you can explain it or give a material that can read on that. And again, I think after doing regression, there are some post tests for validity, things like that. Is there any material you can share regarding this, please?
Okay.
Thank you.
So that's a very good question you asked. So the point is that regression modeling shouldn't just be something the machine does for you and the machine tells you everything to do. The approach is almost like, oh, the machine tells me what to do, then the machine does it, and then the machine tells me whether it's fine. It's like, so what exactly is your role in all of this thing? It's not a machine-driven it should be an intellectual exercise where I am trying to explain the world, and I am okay. Here, from my expert knowledge, here are things that should be considered. for example, as confounders or as covariates, right? Model building should be based on a solid understanding of the subject matter and on a careful selection of variables. So that's why I said, always start from a blank sheet of paper. Always start from, DAGs. You have to understand DAGs, right? This figure, you should be very familiar with variable selection. What are confounders? What are collinears? What are covariates, right? How does this factor into the research question, right? This is your ABC of model building. It is so. Now, for books, I would suggest you read books on causal inferences. Not that you are trying to fit causal models, but because causal models just have a higher expectation or higher requirements, a higher threshold for validity. So it's like aim for the sky. If you miss, you hit the birds. So if you build your models as though you were fitting a causal model, you will always consider issues of variable selection very coherently. I shared a very good link for a book on causal inference the last time. I'm not sure if you were there. But this is a great book for reading in general in terms of understanding causal modeling, right? In terms of like confounders and all of that, and how those play a key role in model building. So I'm sure there's simpler texts, but if you really want to have a solid grasp of what measurement is all about, like what are we even trying to achieve when we measure associations or relationships, right? It's very important to build a very solid understanding of what all of these things mean. What is confounding? What is selection bias? How do we control it in models? How do control for selection bias, for example, in terms of missing values? What are inverse proportionality weights and what do they control and all of this good stuff, right? So I would definitely recommend you read this to just build foundational knowledge first, so that you understand, first of all, what are we even trying to do when we fit models, right? And then you build on that. So that will be my recommendation to you. Okay, any last questions? Lungile.
Yes, I'm checking, sir. And those who are requesting links, one of my colleagues has been posting. Please check them. LinkedIn, evaluation, all the links were shared. Please go through them. There were many questions. I'm just looking for them. And I'm sorry to everyone whose question has not been answered. I might have missed it as some started posting early on during the session. Okay. All right. Maybe we'll end it here today.
All right, sounds good. All right, thanks everyone for attending, and we hope to see you next week at the next session. Enjoy the rest of your day.
Thanks a lot, Dr. Gaku. You've been wonderful since the first session. Is he still here? Oh, he's gone.
Yes,
Oh.
I'm here. Yes, yeah.
Thank you. There's a lot of appreciation here on the chat box. People are appreciating.
Well, if they're appreciating, then they should post their certificates on LinkedIn. That's the only way. That's the only appreciation I'm going to take. All right. Thanks, everyone.
Indeed.
All right. Ciao.
Thank you. Thank you, everyone. We hope you have all the links. Please don't ask for the links after the session, especially the certificate one. Evaluation. Okay. Immediately after each session, the names of participants are sent to our colleague who sends the certificate. So every time, please make sure if you're here, make sure that you immediately complete it, and so that we don't have to always go back, to previous sessions or previous links. So let me share it. Where is it again? Information. I'm searching for the evaluation survey. Just a second. All right, there you go. Ebele, what are you looking for via email, please? We do send emails, but most of the times it's thanks, Evangeline. You've been with us since day one this time. It's been a long time. Thank you. Eddie Jike, I was asking, what are you asking for via email? The links. Yeah, we do share them, all the links via email. Please do check. By Monday, everything will be sent to you, including certificates. Okay. You all have access to the chi-squares platform. That's where Dr. Agaku was calculating the sample size. You can also create surveys. So here's the link. Please try it out. Play around. You can also, yeah, if it's your first time, then you have a lot to learn. Here are all the links. Please just copy this whole thing. So here you have the LinkedIn link, WhatsApp, YouTube.